Hi, it's Amelia here from Undercover Architect. In this video, I talked to Daniel Kress about Passivhaus. So Daniel is really well placed to teach us about what Passivhaus is and how it differs from solar passive, passive design, and other sustainability design measures that you may have heard about. Daniel is an educator in the Passivhaus certification course for both designers, professionals and tradespeople. He owns his own business, Smartplus Homes. He's got a background as a civil engineer and a carpenter. He's German by nationality, now lives in Australia, and he's passionate about educating professionals and homeowners about Passivhaus. He's on the board of the Australian Passivhaus Association. He knows his stuff. So enjoy this video, enjoy learning about Passivhaus and how you can use it to create a home that's sustainable, energy efficient, and really supports your health and well-being. Well, Daniel, it's great to have you here. Thanks so much for joining me. I'm really excited to be talking about this topic with you because it's a big topic. There's lots of information to dive into. It can be really confusing for the uninitiated to really understand what this all means. So perhaps you could start by explaining to us, what is a passive house? What does that actually mean for a homeowner who's building or renovating?
Yeah. First of all, thank you, Amelie, to have me and giving me the opportunity to help the people out there that you know regarding Passivhaus. And Passivhaus is actually the easiest way to describe Passivhaus. It's a standard, an international standard that allows you to build any building so that it's performing and you have a healthy and sustainable house afterwards. That's more or less what it is. Yeah.
Okay, all right. So this obviously then is about creating energy efficiency and sustainability and health and well-being. So it's a complete package, isn't it, in terms of a living environment for a homeowner? So those are obviously some of the key benefits. What do you see really being those key elements that really improve people's lifestyles and the performance of their home when they take on building or renovating a passive house?
The biggest one, I think, is health and comfort. Like, this is where it really goes to, and the health part is still not fully understood, especially by the government, because every house needs ventilation, mechanical ventilation or controlled ventilation. The problem is, if you don't have controlled ventilation, we have accidental ventilation, and then you may have good air quality in the house, or you may not have good air quality in the house. So the real benefits is that you have a healthy and comfortable house, and on the same side is sustainable. So because there are two things that we always have to think of: health and sustainability, and that brings it together.
So it actually sounds like this is an opportunity to really control the environment of your home in a way that not designing in this way, would enable you to do.
Like, it really separates the external environment from the internal environment. So while the external environment is going wild and we can't control it, the internal environment stays stable the whole year round. And that is just done by separating external from internal, like thermally, from the airflow, from moisture, from temperature, and then we're having our stable internal environment. Yeah.
Okay, gotcha. So in terms of those different things, when I've looked into passive house design, there's obviously a big difference between, and we were talking before we jumped on the interview, between passive design, solar passive and passive house. I know a lot of people get confused about that. What are the key differences between those things? Like, what sets passive house apart from just straight solar passive or passive design?
Simplest said is, like, passive house is solar passive in steroids. Like, so like solar passive and passive design comes like if you speak in the modern way, like in the 70s or so, that's where it has its roots, where everybody tried to build like these houses that don't need energy and like being off grid and all these ideas. But in that time, we haven't even put the physics really into consideration. Even now, you don't have a program that is calculating you how many kilowatt hours you're actually using in the house at the end of the year. What's your bill? With Passivhaus, that has changed. Passivhaus is taking the solar passive, like with orientation, shading, size, all that is still the same, and is putting the physics, the building physics into play. And at the end, you can say that's my bill at the end of the year. That's the size of my heating and cooling system that I need, and that's my bill that I'm paying. So that's mainly the difference, and really putting science into play and having a figure that you can look at.
So when you're designing a passive house, then can you model all of these things in a predictive way and then determine, okay, based on that, I'm going to have to make these choices and selections about the house. That means that then my bill's only going to be this much. I'm going to be able to keep the air temperature at this. Is that how the ability that a passive house gives you?
Exactly. Like we have, for example, the Australian like National Construction Code. And the mistake in that calculation is about 700%.
What do you mean by that?
By what the figure is actually showing you. You know how many kilowatt hours you have with your calculation. What you actually need at the end is a mistake up to 700%.
Wow.
So it's a huge difference. If you look to the German, the French, and the Swiss, the difference is up to 300%. And Passivhaus has a difference of 100%. So means if you need 15 kilowatt hours per square meter, it could be up to 30 or it could be down at 7.5. So the reason for that these big differences between what we actually calculate and what is actually happening is the end user. Because you can always open your windows in a passive house, you can always use the house you want to, and that has an impact on your heating bill at the end or your cooling bill. And by this, you have still an impact of 100%. But overall, when we're taking like hundreds and hundreds of houses, we come really exactly to the like a difference of maximum 5 to 10% to what we actually calculated with all the houses. So yes, we can calculate the demand upfront, but then we have the problem, we have to control the quality on site as well. Like in the moment, we only look at, like if you look to the National Construction Code, we have our plans and we make our decisions on the plans, what is actually our energy performance. And we're not checking what actually is installed, what has been done on site. We're not testing air tightness, all that bits and pieces. So Passivhaus is doing that all together, and you have control over the time. And then you have a separate certifier that hasn't been involved at all. And by this, we're really coming to the results that we want. Yeah.
Okay. So you're basically, as part of that design process, you're making selections and choices. You're modeling what the appliances are going to use in terms of energy requirements. You're looking at what the insulated qualities of the walls and the windows and the roof will mean in terms of the temperature differentiation between the inside and outside, and then what you'll need to do in terms of energy use to rectify that based on trying to achieve an indoor air temperature. You're looking at the lighting and any other, sort of hot water, those types of things. And you're basically then calculating a total amount of kilowatt hours per year in terms of what that occupant's going to need. But you're saying that the variable is that the occupant then might open a window, or they might leave their heater running for a little bit longer than intentionally planned, or that type of thing. Is that sort of what you're talking about in terms of that 100% variation? I'm just trying to understand that a bit more.
Yeah,
so,
like for example, we're all humans. So assume we're building a passive house, we think we're doing something good for the environment. So we say, I don't want 20 degrees, I want 22 degrees in my house. So because I want more comfort, because I'm paying for it and I'm doing something for the environment anyway. So this has already an impact. So we have calculated to a low temperature of 20 temperature, but they actually heat it now up to 22. And then we're having that heating thing. Or as well, in the summer, they're opening the window and they feel the cool breeze coming over their skin, and it feels like the external temperature is lower than the internal temperature, but in reality it's 5 degrees warmer. Only because of the velocity we are feeling on our skin, it feels cooler. And now we're actually heating up the house without thinking of it. And then we're closing it and think, oh, it's really sticky in here. And then we have to get that temperature down again. So that's the reason I recommend to use a thermostat to check the temperature external before I open the window, and not the feel of the temperature. What Passivhaus is calculating exactly is your heating and cooling demand. And then you get exactly your demand and your loads. So your demand is your heating bill at the end of the year, and the load is telling you how big your heating and cooling system needs to be. So this is what Passivhaus is calculating really, really exactly. And then we have another figure, it's called PER, prime energy renewable. And that is actually how much energy needs to be, do you need to run the whole building, but not like the figure that we see there is not the figure that we actually have on our heating bill. That's the figure that we actually need to produce. For example, out of 1 kilowatt, like if you have 1 kilowatt of electricity in our house, we probably need 3 kilowatt of coal. So it actually looks at this 3 kilowatt of coal instead of this 1 kilowatt of electricity in the house. So it's thinking more on a community as a whole. What is the energy consumption? However, there is like on that sheet as well a figure that tells you how much energy you're using in the building as a total. Yeah.
It sounds really complex in terms of these calculations. Is that why, because it does work it out to such a higher level of accuracy, it's looking at those inputs versus the outputs and the heating and cooling loads and those types of things, that it can be so much more accurate than, say, the National Construction Code software sort of system? Is that the biggest difference in it, just the level of sophistication, I suppose, of the Passivhaus computations in terms of how they work that out?
Yeah, for sure. Like you have more data entry in a Passivhaus, like in the PHPP. That's the Passivhaus planning package that we use for the calculations. However, the software in the background is doing all that stuff for you. Like it's such a strong tool. Like it gives you everything. It gives you the daily temperature swings, the maximum daily temperature swings. You see the annual swings. You see everything in there. So even if you have done the Passivhaus designer course and you're now going into the industry, it's the basics, it's the beginning. And you will find, I'm even finding now after years, still like new charts in this software that giving me a completely new insight. So it's a really strong and massive tool. The use of it is actually not too difficult if you learned how to use it. Like it brings you really through the process, through all these different sheets that you have to enter the information. So that is not too difficult, but the power of that tool, what is happening in the background is like massive.
Okay.
Yeah.
So from what I understand about Passivhaus, it really looks at the building as a complete system. You know, we've sort of talked about these elements that it's calculating and measuring to see the performance of the house. I'm just going to read through some of the things that I've, you know, in my research, I've sort of understood it looks at, and then perhaps we can talk a bit more about it. So it looks at obviously the passive solar design and the landscaping to look at how the sun and the shade is working on the home, so that can be managed to help manage the indoor air temperature. It looks at the insulation, so how much heat or coldness is moving sort of from outside to inside and vice versa. It looks at the window technology, so what is the heat transfer between through the frame and through the glass from inside to outside and vice versa, because the window is obviously the most permeable part of the home. It looks at the air tightness, so and that's something I want to talk a bit more about as we move forward, because I know that there's a conception about Passivhaus that you can just never open a window, otherwise the whole system fails. So, but obviously air tightness, and it's, as you were saying, we've got that controlled versus that uncontrolled air leakage difference. So, but there is obviously an air exchange system that happens in Passivhaus to do a managed ventilation system. And then there's that ventilation component, so either natural or mechanical, again, to manage that heat transfer. And then there's space heating. So looking at the space heating from appliances, from lighting, from the occupants' body heat, and looking at those heat recovery systems that Passivhaus uses that I'd love to talk a bit more about. And then, of course, lighting and electrical appliances and their energy use through renewable resources or very low energy requirements. So can you just talk me through, there's obviously a lot of components to that. I mean, so it's not like just a case of going, okay, we're going to build a 3-bedroom brick home and then we're going to plug it into the Passivhaus, you know, assessment system, and it's going to tell us what we need to upgrade and downgrade. You know, like this is actually starting from the bare bones design approach, using the right professionals who understand this stuff and are certified. Like what do people need to take into account when they start sort of embarking on this and thinking about all these systems and not getting overwhelmed with the choices and the selections?
Yeah, like first of all, we have a time frame of 45 minutes, and the normal course is 80 hours, and that's the basics. So,
Daniel, you've got to make everyone experts inside 45 minutes, okay? Challenge done.
I would like to get this brain connected to the net and everybody can get the data, but it might be an overload for some as well. So it goes even to how many times are you using a tap in a house and how long is the plumbing of that tap and how much water is in that piping. And that energy use that is actually then helping to heat the house if it's the warm one, or it's cooling the house if it's the cool one, is all calculated. So that's the intensity that we go into. Wow. But we don't want to go into that intensity. So let us go through the basics and what it is all about. Like there is 5 components that you probably know of the 90 seconds, Passivhaus in 90 seconds, this little video. And these are the main components that we have to look at, plus size and orientation. Like the biggest one is size. Australia has the biggest houses in the world. And we don't have a higher comfort only because of having bigger houses. You probably do that a lot. You probably agree with me that we often have about 30% of unused space in the houses that is just corridors and places that you can't use. So smarter design, spending time on designing saves you so much money in the long run. So that's the first one. Reduce the size of your buildings. You don't need 250 square meter for 2 people. It's not needed, and you're not getting better comfort in that. So that's size. Next one is orientation. Orientation always helps. If you only have windows on east and west, you have overheating, like it is known. So try to have really your north-south orientation with your windows if possible. Windows is another topic, but I would like to start from the basic. So the first one is the thermal insulation. Thermal insulation is like in the winter, you're putting your winter jacket on. So that's your thermal insulation. That's what we're doing with our houses. We put winter jackets onto our houses, but as well summer jackets. Like if you think of your esky is keeping the internal cold. Like the energy, the heat is not caring if the energy flow is going that way or that way. So the heat is going in both ways. So it means
for the listeners, Daniel's pointing in one direction and then in the other. If you're not watching this on video, so.
I thought on video, yeah. So the energy flow, the heat is not caring in which direction it is going. So your thermal insulation works in the summer as in the winter. Yeah, so that's the reason we are in a really good climate over here, like especially in Perth, where we are in the middle and we use it the same amount in the summer as in the winter. So next one is thermal bridge-free construction. So a thermal bridge is a point where heat is leaking through the building envelope because we have a thermal conductor, so a material that is actually letting heat through really, really easily. Similar, again, with a person, if you're out in the cold, say you're skiing and you're skiing down the hill, your face is getting really cold. That's the reason we're putting a skiing mask on it, and that's then reducing our thermal bridge in our face. So that's a thermal bridge. And we want to eliminate thermal bridges because thermal bridges are, first of all, like an energy loss, but as well a health risk. Because where a thermal bridge is, we have a colder surface in the winter, and where a colder surface is, we have condensation, and where condensation is, we have mold. And we don't want mold, because mold is not good for us. Mold actually increases the chance of asthma by 40%.
Wow. So in a house, that might be something like the window frame, for example, that thermal bridge. Yep.
Mm-hmm. Yeah, that one is the window frame or even the corner of a house. Mm-hmm. Because like if it's an external corner, you have a change of direction. A change of direction is as well a thermal bridge. For sure, we can not only build a straight wall, like then we can't create our box to live in, because we live in boxes, we look in boxes, we use boxes, we drive in boxes. It's all boxes anyway. So we have to then over-insulate this corner so that we don't have a thermal bridge there. Yeah, so that's the way to look at it. And then that's thermal bridges. Next one is the air tightness that we probably go into more detail later. Air tightness is the air is transporting moisture and heat. And we don't want that moisture is leaking into the building, and we don't want heat leaking into the building or leaking out of the building. Then as well, because while the air is moving through the building envelope, through the build-up, the temperature is dropping. and then the relative humidity comes to a dew point, and then we have condensation issues in the middle of the world, and that's mold that we never see. That's structural damage, that's mold, it's not good. So we want to stop that, and we only can stop that by making our buildings airtight. That doesn't mean you're putting a plastic bag over your head, what people imagine with it. It's making the building airtight means you don't have uncontrolled ventilation, like it's controlled ventilation by the heat recovery ventilation system. That's the last part. The next one is the windows that we just spoke shortly of it. Windows, we want to have connection to the outside via natural light. We want to look outside, so we want to have natural lighting in the building as much as possible. And as well, we want to use the heat that we're gaining through the windows in the winter time, but we want to block it out in the summertime. So there is now the solar passive design coming in a little bit with our overhangs and shading devices, but often they're not good enough because we have a really hot day in the winter and now the sun is coming in and is overheating the building, or we have a really cool day in the summer and the heat is not coming in. So because it's really cloudy, for example. So this is working in an ideal world, this solar passive design, but not necessarily in reality. So that's the reason we use high-performing glass that is actually designed so that heat is coming into the amount that we wanted to have in. And then we may have operatable blinds externally, not internally. Soon the heat is passing the glass, the heat is in. So everything we do on the inside of the glass is not helping. It only helps with the radiation. So we have to block it externally, so on the outside of the glazing, not on the inside of the glazing. That's the first one that is often misunderstood. And then have external shading devices. And in the PHPP, like the software, we see every single window what's actually the heat gain or the heat loss. So we can say this window needs a bit more shading, this a little bit less, and then you can use your funky architect designs to create the different shadings. So there you can go really wild theoretically, and using like curved shapes and everything, like everything is possible. Like I've seen a lot of things there. And then the last one is the heat recovery ventilation. Heat recovery ventilation is doing two things. The ventilation is a health requirement. And ventilation we need in every building, not only in an airtight building, not only in a passive building, not only in a high-performance building. We need ventilation in every building because of health. We are in these houses and we are using these houses, we are breathing, we are creating CO2. And the CO2 levels are rising dramatically even in a not airtight house. In a not airtight house, you might have by accident a good air quality, because the pressure difference at this time of day or whenever or time of the year is big enough to create this necessary airflow. But you may have even too more airflow that we know all this drafty experience that we have. So it's a health requirement because the CO2 levels rise, the VOC levels rise, the particle levels rise, and we want to keep them low, as close as possible to the external environment, because the internal environment that we are creating is an artificial environment. It's not our natural habitat. Our natural habitat is outside in the wild, but we don't want to lie out in the grass. We want to protected environment. So, but by creating this closed box, we're having not the same conditions than we have externally, and we're spending 90% of our time indoors. So that's the reason we really have to get this fresh air into the building, and that's a health requirement. On the other hand, we have the heat recovery part. The heat recovery part is an energy requirement and a sustainability requirement, because the heat recovery part is recovering our heat, so we are getting this fresh air in and this stale air out, and they are transporting the temperature theoretically from the inside to the outside, from outside in. In the heat recovery part, we're letting these airflows pass each other, and while they are passing, they're transferring heat and, if wanted, moisture. So we can have a relative humidity recovery as well. And if we do that, we keep the internal temperature, and the external temperature, the external. And we're able to bring it up to a recovery of 96% now with our...
In terms of you can get 96% of that heat back out of the building.
Exactly.
Okay.
So it means we keep the internal temperature to 96% the way that it actually is.
Gotcha.
And the external gets like his 45 degrees back there as it was coming in. So this is
That's
heat
amazing.
recovery. It's amazing, I know. And you have to have at least 75% for passive house. So yeah, and I calculated it like you have a recovery, like the energy that is in there, if you have to heat it and cool it over the year, you would have a recovery of about $300 a year easily.
Okay.
In a new build and in a traditional build as well. Like the recovery is more or less always the same. The big losses in the traditional houses is through your single glazed windows and through your uninsulated walls or roofs. So the recovery more or less works the whole time, and $300 saving every year. Your unit costs you $3,000, so in 10 years you have to pay it anyway, plus the ventilation's in there, so probably in 5 years you have paid the additional cost for the heat recovery part. So
Daniel, I think you did really well in terms of a crash course of what passive house is.
Yeah.
So in terms of that heat recovery, and anybody who's listening to this podcast or watching this video, it can seem really scientific, and I mean it is. That's ultimately what passive house is about. It's a measurable science that actually helps us understand, not just stab in the dark and have a guesstimate about how our house is performing, but the software and the science behind it and the research behind it enables you to really dive into the nitty-gritty of how your house is going to perform before you actually go investing money in it, so that you know that the investments you're making are going to have returns and what the length of those returns are going to be. So I think if this is something that interests a homeowner, it's probably one of the most tangible systems that they can use to really understand how their house is going to perform over the long term. And it's proven, and it's been, obviously been used and improved since, the 80s when it first got introduced. So I think that heat recovery system is probably the most mysterious component of all of it, So,
It is, yeah.
So is that actually a unit that then has ducts that run around the house? Like, what does that physically look like in a house installation?
Like this unit is the lung of the house. That's the way to put it. The lung. Yeah, that's the easiest way. And then the lung is connected via our blood streams that is transporting the oxygen in our body, but in this case, the air. To the different rooms. So you have this magic box that is doing all this recovery and the filtering. So all your air you're getting into the house is filtered. So people with hay fever, they will love it. This filtered air then goes into the rooms like sitting rooms or bedrooms. And then it goes through your hallway over to your bathrooms, kitchens, toilets. And there it's extracted. So everywhere we have smells and moisture, you extracting, and all the places where you're spending most of the times, like sitting rooms and bedrooms, you are supplying the fresh air. And then you're bringing it over, so you never have, your house is not smelling like cooking any longer after. Like you don't have moisture coming out of your bathroom any longer. You could even design the system so that your mirror in the bathroom is not fogging up any longer.
Wow.
So like there's a lot of we are reducing energy, but we're gaining so much on comfort and so much on health. And passive house is only the first step, and it is a step. We have to do this step. If we're not doing the whole concept of passive house, not certification, I'm not speaking of certification and do everything like to the nitty-gritty that is in the PHPP, but the concept of passive house is the first step. If you're only doing a half a step of that, we tremble. Like if you're going up a step and we're not getting the whole step, we are running against the step and then we tremble. And that is what is happening if you're not doing the full step. And then we're creating health issues because of mold growth, of moisture issues, of all that things that happen. So passive house is the first step. And then there are more steps to come. We come then to the plus energy housing, where you produce energy in the house. Then you come to the smart housing, where you then share energy smartly with all the others. And then if you put that all together, you come to Smartplus homes.
Gotcha.
Yeah.
Nicely done. So that's the thing. I mean, I think that, and we'll be talking in a future episode to an owner who's building a passive home, so that, we can understand from a client's point of view sort of what the journey was for them embarking on this. But I think that it is really interesting to think about this kind of being the way of the future. I've been reading a lot of articles recently because at the time of recording this, one of the largest sort of prefab housing suppliers or prefab building suppliers has just gone into receivership. There's a lot of conversation around how just the lack of innovation that's happened in the construction industry, in every other industry, we're seeing innovation happening on a regular basis. But the construction industry itself is still pretty much, in terms of some of the materials have changed and, those types of things. But really, when you look at the pace of change in other industries, the construction industry hasn't really done a lot of change, but comparatively. And so, I see that Passivhaus, it's a really exciting opportunity for people to understand just what's possible when they're building a new home. And the thing with this is that the more demand there is for it, the lower the cost of these additional measures are going to be, and the more access there'll be to certified consultants and those types of things. It won't be this fringe kind of, experience. It'll be something much more mainstream. So can you talk to me, is it only applicable to building new, or is it something that somebody consider if they're renovating a home as well?
There are standards for renovation as well. That's ENAFIT. So there's retrofitting options as well, where the standards are not so high, because there are especially air tightness is one of that points that is really difficult in retrofitting, so there are steps of doing that as well in renovating houses. And there are ways, like if you do it right. So if you're replacing your windows, replace them already with the quality of a passive house. Then think about the air tightness around the windows. Then you have to think of the air quality as well. So there are some steps you have to do together, and the other steps that you can do separately. So if you are changing the external render on the house, then put as well thermal insulation on, and then put the render on again. Like there are like steps that you should do together, and not necessarily say, I want to do now everything in one go. But for example, your external render has another lifetime of 15 years, so do it in 15 years, because you're just creating costs that you don't need. Or your windows, the windows with the single glazing, it probably makes sense straight away to change them. There's everything, like I see it similar to a doctor. You can't say to a patient via the phone what you need to do. You have to see the patient, and the house is the patient. And I have to, like every person that is taking it seriously has to see the patient first before you actually can tell what is the right approach. And that's the reason we can't do that via phone, like the consulting on renovation. New builds, no problem, but renovations, we need to be at the place and look at it and then say, yeah, you could do this, you could do this, you could do that. Yeah.
Just in terms of seeing what you need to physically improve based on sort of what's happening in situ. So I think too, it's really good that you've pointed out just how key ventilation is in all of this, because I know that, we had a building biologist on the podcast a few episodes ago. She talked about the issue with creating air tightness without ventilation because of then condensation and mold being a big problem in homes. Yeah. Obviously, if you've got materials that are off-gassing, volatile organic compounds and those types of things, and you don't have ventilation, that's going to cause issues with health and well-being. How, in terms of those misconceptions that people have around Passivhaus, one is we can never open a window. Like what are those kinds of, misunderstandings that you see? And, I know another one I know is my house is just going to have to look a certain way, or I'm going to have to live really frugally. I'm never going to be able to kind of, splash out and have the heater on longer than I'd planned because everything's been calculated to an nth degree. Like how do you sort of coach people through those misunderstandings?
Okay. So first of all, windows can be opened. Like that's the biggest one. You can open the window and you open whenever you want them. You're the user, it's your house, and I'm not coming along and slapping on your hand and saying, no,
we didn't design it this way.
Exactly. And you're not getting a necklace with like electrical current that is
gets buzzed from a remote location. You opened a window.
So yeah, like that's not happening. So it's totally in your control. You can do whatever you want with your building. It's your house. Second, the heat recovery ventilation is not a heater and it's not a cooling device. It's recovering heat. So in a passive house, you always have a little bit of heating demand and cooling demand left. And the reason for that is it would be uneconomical to go the whole way, because then you have to triple the thermal insulation to actually come to that point, and then it really limits you in the design. So that's a big issue. Another big issue, that's something that people misunderstand when they say, yeah, I have a heat recovery ventilation system, I don't need any heating. No, you need a little bit of a heating. Normally a split system is enough, or 2 split systems. I normally say 1 per 100 square meter, and then you're fine. Overheating is often an issue, that people say passive houses overheat. And as well, the regulation of passive house allows you 10% overheating. That's a lot of overheating, and I wouldn't build a house with 10% overheating. I would never go above 5 if I don't have a cooling device. If I have a cooling device like a split system, then I don't have that problem, because the cooling is needed when energy is for free.
Okay. Because
you have your solar system on the roof, and you can use it then directly for cooling.
Okay.
So the heating is far more energy sensible, because it happens to the times when we don't have energy available, like in the cold season.
I get you, when your solar system's not being juiced up with the sun.
Exactly.
Because it's overcast weather and those types of things. So the heating system is the one that you can supply energy for, but the cooling system is the one that's going to be supplied by renewable resources, because you've got solar on your roof. Am I understanding that correctly?
Yeah, like exactly that. Like the cooling happens when we have free energy or really cheap energy available, and the heating is happening when there's a really little amount of energy. And we even have to have seasonal storage, like from summer into winter, because in the summer we have more energy than in the winter, and that is the expensive part. Soon we have to make out of, like, in a totally renewable energy network, that there's no coal or no natural gas or oil or anything like there any longer in the mix. Then we have to store from summer into winter, and that would be power to gas. So means we are splitting water into oxygen and hydrogen, and then we're putting CO2 to it, and we're creating methane. And methane is like natural gas, and we're storing that like natural gas. And then we store it from summer into winter, and then we bring it back to electricity and heat the house in the winter time.
Oh,
so that is like, yeah, like. That could be a whole other episode, like talking about how that works. So that's the reason. Overheating, yes, passive houses can overheat, but it's not such a bad thing, because you have free energy available anyway. Because putting you had a podcast about photovoltaic just now, like solar systems, and they said like it's always economical. I guess I haven't listened to it, but it is always economical to put it on. So and then you have the energy available anyway. Was there more questions?
So, and it has to look a certain way. That's another thing. People think that they're going to have a house that aesthetically is going to be look a particular style, because of all of these design devices that are used to make the house a passive house.
Yeah, like the design is not necessarily limited. Like, for example, there's a limestone house. If you Google that, that's a passive house, and that's architecturally really interesting. Yeah. So, and it's not just a box. However, go into your rooms and check if it's a box. Every single room is a box. It is always square, 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 square. Okay, my sitting room has now a little bit of corners in it, but normally it is a box. So I always think, I don't want to live in a box. You're living in a box. That's reality. You know? And I normally say, because every external corner that you're putting in, and every shape that you're changing, like if you're changing shapes, you're increasing thermal bridging. If you increase thermal bridging, you have higher energy demands that you need to then compromise, or like not to, not compromise, to eliminate by more thermal insulation over the whole building, or better windows. So you can build more or less any shape with a passive house. However, it's a question of money.
Okay.
Then I would, like, for the architects, I say try to work with surfaces and not with shapes.
Gotcha.
Create a box and then change the surface, change the material on the surface, the color of the surface. Maybe have a feature wall that comes out, but keep the thermal envelope a box.
Okay.
As much as possible.
And that's
because that makes it cost effective.
Yeah, that's going to be cost effective and energy effective as well. So, All right, so we have covered a lot of ground, and we're going to be diving into more detail in coming episodes about Passive House from different points of view, which I think is going to be really helpful for the UA community to understand this from, you know, the client's point of view, an architect's point of view, builders, certifiers, consultants. It's a really fantastic topic to understand in more detail. If somebody's wanting to sort of start thinking about this for their new home or their renovation, what are your big tips that you recommend in terms of them embarking on this journey and not getting overwhelmed and too confused about it, you know, and really sort of being able to find the right people to work with? How do you recommend they go about it?
Like passive house design starts as early as town planning. That's the reason in Europe we have a lot of town planners. So get your passive house designer involved as early as possible. It will save you thousands, $10,000s of dollars just by getting a professional involved early on. And the problem is, if you're coming to a passive house designer with your fancy design that you are totally in love with, and he looks at it and thinks,
Or she.
He or she,
You're trying to just pump it through that system.
Exactly. Like you have made your mind up already. You like that. You have done so much work in that already. And now you get a completely different perspective from the performance, not only from the aesthetics. And then you run into trouble of paying a lot of money to get what you actually designed, or going back to pay more for the designer to get a more cost-effective solution. So get your professionals involved as early as possible. Get your builder, like have an interview with 3-4 builders that you think they could be worthwhile working with, and then say, yeah, I work with you. Like I work with you from the beginning, have you involved, and have all these professions involved. Like the architect often has 90% of the time, but he has only 10% of the knowledge. And all the other professions like builders, engineers, passive designers, all them, they're coming in this last 10% with the 90% of knowledge and then have to work around this design that was already created. So try to get everybody in line really, really early on in your project, because then you get far more cost-effective and far better results in doing so.
Yeah, it strikes me that this is something that you really need to work with certified professionals. You teach the certification course, and there's a growing group of certified professionals across the industry in Australia and in any place. You know, we've got listeners and viewers who watch from all parts of the globe, and so Passive House is something that has really, I am seeing grow, and there's associations in across various countries that then have the ability for you to find certified professionals who can work with you in this way. And it's really, as Daniel said, getting the team in place up front so that everybody's working collaboratively. That's going to be the way that you really work to create this holistic home, because it's a very much a holistic approach. This is not something you can do piecemeal, and it's not something that you can just apply to a finished design. You do need to use this as an approach overall. You can still have the home that you want in terms of functionality, look, style, and layout, but you're going to be working with the unique qualities of your site, your climate and your location to make sure that you're really lowering the energy use of the home, and that you're creating something that's going to be comfortable and energy efficient and really support your health and well-being. So I think it's just been such a fantastic crash course in Passive House, Daniel. I can't thank you enough.
May I say something to the end? Like, because it's not only about Passive House. Like it is bigger. Like the whole thing is far bigger than Passive House, and the Passive House principles need to be applied. And the reason for it is health, 100%, and sustainability. If you want to achieve the goal of only 1.5 degrees global warming, then we have to act. 23% of the Australian energy consumption comes from the building use, not from producing buildings, only from using our buildings. And by Passive House, we can bring that down to probably 5% from 23 to 5. So this is a huge opportunity for us to really reduce the energy consumption and get to our climate goal that we really have to achieve, or we must achieve. If we want that our children and children's children have still a planet like we know it, we have to act now. Passive House is not a trademark. Passive House, there is no, everybody can build a Passive House. You don't need to be a certified Passive House designer. You can call your house a Passive House. However, if you say you have a passive house, you want a passive house, and you are delivering a passive house, you must deliver. Passive house is really clearly specified, and if somebody says I'm selling you a passive house, I must fulfill these requirements. There are law cases out there of people, they were selling a passive house and it has not been a passive house. So even it's not a trademark and it's not like something that is protected. The standard is really clear and it's globally, worldwide available. So if a passive house is offered, passive house needs to be delivered. And you don't need to go through certification. There's no need for that. You can build a passive house. Apply the passive house principles to everything. The certification is only giving you an additional safety factor because the designer is then checked by the certifier. And another pair of eyes is looking over it. And that's the reason it's so valuable to use that, especially in an industry that is so undeveloped and is really new. And there are a lot of things that can easily be done wrong. Passive house is not rocket science. It's simple. It is really simple at the end. Like, it is really complex. And to get your head around it is not easy. That's the reason we have our professionals. That's the reason we have certified passive house designers that actually pass the test of the Passive House Institute. So we really, it is simple. It's not difficult. We're just separating external from internal. That's what we are doing, and creating a nice, warmy, cozy environment internally. Yeah.
That's fantastic, Daniel. Thank you so much for your wisdom and your advice and your knowledge and sharing that with the UA community. It's been fantastic having you on the podcast. I know that everyone will find it incredibly helpful in understanding more about Passive House. So cheers.
Thank you, Amelia, and it was great talking to you. And yeah, it was nice to be here. Thank you.